Multiprocessor is a system which has more than one CPU connected together with the memory and peripherals. Multiprocessor is used to speed up the system execution time. It is classified as multiple instruction, multiple data stream (MIMD) system. The term processor in the multiprocessor can be referred as either CPU or input-output processor. Mainframe computer, supercomputer, and the multi-core processor are some of the examples of multiprocessor. Shared memory multiprocessor, or called as tightly coupled multiprocessor, have access to all the main memories in the system and can access any data from any processor in the system too. All CPU in the system share the common memory. This type of multiprocessor can help improve the performance at the high degree of the interaction between the tasks. Distributed memory multiprocessor, or known as loosely coupled multiprocessor. Each CPU in this type of multiprocessor has access to their own memory. This multiprocessor is the most efficient multiprocessor when the interaction between the tasks is minimal.
Okay, I'm going to continue this discussion with parallel processor organization. For the introduction, parallel processing is a method in computing of running two or more processors, or also known as CPUs, to handle separate parts of an overall task. Breaking up different parts among multiple processors will help reduce the amount of time to run a program. Any system that has more than one CPU can perform parallel processing, as well as the multi-core processor, which are commonly found on computers today. As an example, the next instruction can be read from memory while instruction is being executed in the arithmetic logic unit, or also known as ALU. The system can have two or more ALUs and be able to execute two or more instructions at the same time. The three models that are most commonly used in building parallel computers include synchronous processor, asynchronous processor which is on memory, and asynchronous processor with a common shared memory. We're going to move on to the organization diagram. Typically, a computer scientist will divide a complex task into a multiple separate tasks with a software tool and assign each part to a processor. Then each processor will solve its parts, and the data is reassembled by a software tool to read the execution or perform the task. Typically, each processor will operate normally and will perform operation in parallel as instructed. Processor will also rely on software to communicate with each other so they can stay in sync concerning changes in data value. Assuming all the processes remain in sync with one another, at the end of the task, software will fit all the data pieces together again. One possible method of dividing the execution into 8 functional units operating is shown in this diagram. Depending on the operation specified by the instruction, operands in the register are transferred to one of the units associated with the operands. In each functional unit, the operation performed is denoted in each block of the diagram. For example, if the process is arithmetic operation with integer numbers, the functional unit that are involved is the adder and integer multiplier. So the register will send both of the unit to the adder and integer multiplier simultaneously at the same time so that the program will run faster.
I will continue with the general specification for multiprocessor. Multiprocessor systems usually have room in the board for 4 or more processors, although there is no minimum requirement. This is different with dual processor systems that are designed for use exclusively with dual processor motherboards. Besides, this kind of processors are designed to work together in handling large database and business transactions, so that there is a much different than parallel processor. Nowadays, most of the processors are surpassing dual processor systems that usually operate at higher clock speeds than multiprocessor, that making dual processors are more efficient at handling high-speed mathematical computation. Furthermore, multiprocessors are divided into two types of coupling, which are tightly coupled multiprocessor systems that contain multiple CPUs that are connected at the bus level, and also loosely coupled multiprocessor system, or often known as clusters or shared nothing multiprocessor. Finally, it is also very flexible to use a BIOS or basic input-output system with minimal multiprocessor specific support.
Next, the general specification of parallel processor. First, each processor implements concurrent programming language and application programming interface API. Concurrent programming language is a programming language designed to support simultaneous operations, hence it can execute more than one processor, while API is an application that delivers a user response to a system and sends the system response back to a user. Second, automatic parallelization techniques is applied to converse code. In order to use processors simultaneously, sequential of code needs to be conversed into multi-threaded code, which requires a few techniques. An example of parallelizing compilers that we can find are Polaris compiler and Rice-Trendy compiler. Other than that, parallel processors include application checkpointing to provide fault tolerance. What this application does is that it saves the parallel program states, so in case of a failure, it can restart from that point. Next, usually any parallel processor structure's main memory is either distributed or shared memory. A shared memory is where multiple processors can operate independently but share the same memory resources. There are two types of this kind of memory, which are uniform memory access UMA and non-uniform memory access NUMA. While distributed memory allows each processor to operate independently and has its own local memory. The difference is that in distributed, changes in local memory have no effect on the memory of other processors, while in shared memory it is the opposite. And last but not least, parallel processing architecture supports both massively parallel processing MPP and symmetric multiprocessing SMP. As I said just now, parallel processors use shared and distributed memory. The shared memory supports the SMP, and the distributed memory supports the MPP.
Okay, now I will explain what are the advantages and disadvantages of multiprocessor. First of all, for advantages, multiprocessor system is high reliability. In this system, even if one processor fails, the system will not halt and will resume or continue their working despite there is a hardware failure. And it is also can share their work between the processor connected. So then, the work is complete with collaboration. That means all of these systems are reliable. Secondly, multiprocessor will always enhance the throughput of the system. This type of system has a higher throughput since the number of processes run by the CPU at a given time is higher. After that, it requires less electricity usage. Multiprocessor CPU consume low electricity than a single processor because this system only execute and run the multiple processes in a few times. Lastly, multiprocessor also more economic system as more work is completed by the CPUs, so these systems are economically good as well. On the other hand, there are obvious disadvantages while handling multiprocessor. Firstly, it is require more complex and complicated operating system. There are multiple processors in the system that share peripherals, memory, and so on. So it is much more difficult to schedule, process, and allocate resources to process than in single processor system. Then, multiprocessor also need more memory space to share memory since multiprocessors working each other. Hence, more memory is required for each processor as compared to single processor system. Furthermore, system will create deadlock. If one processor is already using an input-output interface or device, then other processor would be unable to use the same interface or devices and resulting in a deadlock. Last but not least, multiprocessors are quite expensive to buy due to the quality and materials used for the processor or product itself.
Next, parallel processor advantages and disadvantages. First, the advantage of parallel processor is it can save time. This is because by doing simultaneous operations, it will shorten the time to solve problems or tasks. Second, one of its advantages is it can save money. Parallel processor can be built from cheap commodity components that require less money. The third one, parallel processor can compute large information. Sometimes problems or informations can be complex and impossible to solve due to limited computer memory. However, the parallel processor can overcome this problem. And lastly, use non-local networks. When the local compute resources are insufficient, the processor will compute resources on a wide area network or WAN. Disadvantages of parallel processor. The first one, consume a huge amount of power. As we know, parallel processor use multi-core architecture, and to run this architecture with more than one functional unit, it will increase the power consumption. Secondly, difficult to debug or proofread. Parallel solutions are harder to implement. They often perform worse than the serial counterparts due to communication and coordination overhead. Next, better cooling technologies are needed for clusters. Higher density server equipment produces a lot amount of heat. Hence, to control the thermal effect, more effective liquid cooling has to be used. And lastly, execution time increase due to certain cases. Sometimes, parallel processor can be disrupted due to cases such as data transfer, synchronization, communication, which exceeds the gain of parallelization.
As for the real implementation of multiprocessor, I have chosen the IBM Blue Gene P as the supercomputer of choice. Okay, so about the IBM Blue Gene P, it was founded in 2007. It is known to be the second generation of the Blue Gene series. Now, the Blue Gene series consists of 3 generations: the Blue Gene L, P, and the latest model, which is the Blue Gene Q. So, its design was made possible through a collaboration of IBM, LLNL, and RG National Laboratories Leadership Computing Facility. Okay, next is the specifications. The Blue Gene P is an evolution from the previous model, which is the Blue Gene L. Next, the Blue Gene P compute chips consist of small private L2 caches, and it also has a central shared 8MB L3 cache, and lastly a dual DDR2 memory controller. Furthermore, it also has twice the bandwidth of the previous model, which is known to be the Blue Gene L. And a single compute node has a peak performance of 13.6 gigaflops. Furthermore, the Blue Gene P compute chips contains 4 PowerPC 450 processor cores running at 850 MHz. Lastly, which is the most important part, is that the cores are cache coherent and the chips can operate as a 4-way symmetric multiprocessor, or we can call it as SMP. So as for the price, it starts at 1.5 million US dollars, and the functionality is used for research on climate modeling that will investigate the impact of climate change on flood forecasting. Besides that, it also helps with crop yields and also renewable energy and the health of rainforests in the region, among others. This is all being done in Brunei, for example. And last but not least, the application of suitability. The Blue Gene P has been used to stimulate approximately 1% of human cerebral cortex.
For the real implementation for parallel processor, the latest product is Supercomputer Fugaku. Supercomputer Fugaku is developed by RIFAE and Fujitsu since 2014, and as the successor to the K computer. It completed on March 2021 and officially scheduled to start operating in 2021. Fugaku made debut in 2020 and became the fastest supercomputer in the world and became the first ARM or ARM architecture-based supercomputer to achieve this. For the specification, it has 158,976 nodes and built with Fujitsu A64FX microprocessor. Fugaku is aimed to be 100 times more powerful than the K computer. Fugaku uses operating system called Custom Linux-based kernel. It uses both Linux and Mac kernel operating side by side. For the memory, it uses HBM2 32GB per node and memory bandwidth of 1024 GB per second. For storage, it has 3 layers. For the first layer, it used for cache for global file system, and temporary file system. The second layer is Ledger-based global file system. The word Ledger is derived from Linux and cluster. Ledger is a type of parallel distributed file system. It generally used for large-scale cluster computing. The third layer is for cloud storage services. The peak performance for this supercomputer Fugaku is 537 petaflops, and the cost to make this supercomputer is $1 million. Supercomputer Fugaku provide access for wide range of researcher and user in industrial and academic field. It also has a design that suit for artificial intelligence application such as deep learning. This supercomputer has partially operationally last year to visualize how droplets that could carry the virus spread from the mouth and also help to find possible cure or treatment for COVID-19.
In conclusion, multiprocessing is the interconnection of more than one CPU with memory and peripherals, which requires less electricity usage. But it's very expensive, whereas parallel processing is a method in computing of running two or more processors or CPUs to handle separate parts of an overall task, which is able to compute large information simultaneously but consumes huge amount of power.